Hello guys, welcome back to series. Before we begin our lesson, I want to clarify something. There are so many definitions of the word arithmetic. It can mean mathematics itself. But let us be clear, for CAPS South Africa, we must understand that arithmetic only refers to linear. Okay? So in number patterns we have arithmetic, meaning linear, then we have quadratic, and we have also geometric. Okay, so let us talk about finite series, and we'll start with arithmetic. So we are going to introduce three formulas which we are going to use. So the first formula is Sn is equal to half times n times a plus l. What is it saying? It's saying sum of series is equal to half of the total number of terms times the first term plus the last term. So if you know the last term, the first term, and the total number of terms, you can calculate the sum of series using this formula. So just remember, if you've got 10 terms, then in total, which is the series which you are looking for, then n is equals to 10. So this would be very useful. And L, if you don't have L, you will have to use Tn is equals to a plus n minus 1 times d. The very first formula which you learned in number patterns, you have to use it to find your L. Then you'll be able to find our next formula. This will become your new formula. So this formula and this formula are the same. It's just that when you don't know the last term, you substitute L with this, then you'll be able to find this. Now, the last one, we are saying you can use, if you know the sum of series, you can use them to find any term. Okay? We used this formula at first to find any term. Let's say you are supposed to find the 20th term. You can use this formula. But sometimes they don't give you enough data for this. They will give you data to be able to find the sum of that series. With sum of series, you can use that to find your 20th term if they ask you for the 20th term. So let's just use examples to see how these formulas work. Example 1. You have this linear pattern. Find the sum of the 6 terms above. So initially when introduced to series, we said you write Sn for sum of series, and if you are adding 6 terms, you write S of 6. So the sum of those 6 terms, we add them like this: 4 plus 7 plus 10 plus 13 plus 16 plus 19. That's the first. Now, let us use the formulas which you've just learned. You can write Sn is equal to half times n. If you know the first and the last term, then that's good. Now we know where n is 6 because that's the total number of terms. So S of 6 is equal to half times 6. The first term is 4, the last is 19. 4 plus 19. So just look at this pattern. They might say from 7 to 16. So your first will be 7, your last will be 16. And n will be 1, 2, 3, 4. Your n will be 4. That's what you would substitute. So just be careful with those things. So if you punch this into your calculator, the sum of 6 terms is equals to 69. So these are the two ways you can solve that. Example number 2. So given that the pattern above is a linear sequence with 50 terms, find its sum of 50. Okay, so they're just saying find its sum of series. This is similar to the previous example. However, why am I putting this example? Because it's going to be a base for the next few examples. We will be referring to other examples using this example. So Sn, you write your formula first. We know the n, we know the a, and we know the l. So we will use this formula. S of 50 is equals to half times 50 times 4 plus 151. S of 50 is equals to 3875. Example number 3. We are still using the same pattern, but in this case, they have not given you n. You don't know what n is. In the given arithmetic series, find the sum of series of the pattern from the first term t1 equals to 4 to the last term 151. So let us write our formula. Sn is equal to half n times a plus l. Okay, you can use this or you can use the other one that starts with 2a here. Whatever suits you, it's all fine. So we don't know what n is. Let's quickly substitute what we have. Sn is equals to half times n times a is 4 plus l, the last term, is 151. So Sn is equals to half times n times 155. So let us find the n. Tn is equals to a plus n minus 1 times t. So n is representing the last term. So what was the last term? It's 151. It's equals to a is 4 plus n minus 1. The common difference is 3. So 151 minus 4 is equals to n minus 1 times 3. This is a 147 divided by 3. We are left with n minus 1 on this side. And this is a 49. We take this to this side, plus 1 is equals to n. N is equals to 50. If you remember from example number 2, n was 50. It's just the same example we are playing with, showing you if you have got some information and you don't have some information, what to do. So let us substitute now. We know n is 50. So the sum of 50 is equals to half times 50 times 155. The sum of 50, let's punch that into a calculator. You get 3875. Just the same as example number 2. But in this question, you had to find the n. Example number 4. This is still example number 2, but with some things being tweaked. For example, in this one, you don't have n again. We are actually looking for n, just like example 3. But in example 4, there's something else missing. You don't have the last term. So let's get into the question. Also, sometimes they give you in expanded form like this. They put plus and plus in between the terms of your pattern, okay, to make it a series. Or sometimes they give you just as the number pattern without these positive signs in between, just like the previous examples. Just take note of that. For the given arithmetic series, you are given the first 3 terms. What number of terms, that's n, of that pattern will from t1, so you are given the first term, give you a sum of series of 3875. So we don't have the last term and we don't have n. We are actually looking for n. And in this case, instead of looking for the sum of series, you are given the sum of series. So it's more like playing with subject of formula. So write your formula. Sn is equals to half n times a plus l. And you can use this, then you can substitute, but I think it's best just to remember how to write this. Okay, so remember we need to find n. So Sn is equals to half times, we don't know what n is, 2 times a is 4 plus n minus 1 d, the common difference 7 minus 4, 3, 10 minus 7, 3, so our common difference is 3. Now we know what this is because it's been given. It's 3875. 3875. If you multiply 3875 times 2, you get a 7750. It's equals to 5n plus 3n squared. N is equals to minus b, minus 5 plus or minus square root of b squared, 5 squared minus 4 times a is 3 times c is minus 7750, all divided by 2a, that's 2 times 3, n is equals to minus 5 plus or minus, let's punch this into our calculator, we get a 305 divided by 6. So n is equals to minus 5 plus 305 divided by 6, or minus 5 minus 305 divided by 6. N is equals to 300 divided by 6, or n is equals to minus 310 divided by 6. N is equals to 50, or n is equals to minus 51.6. Now remember, n is always supposed to be a positive integer. So the final answer, S of 50, is equals to 3875. Example number 5. Now look, sometimes they don't give you those word problems. They'll give you something in short form like this. So you should be able to read this. So the sum of series, or the sum of series, is equals to minus 20. They gave you this. So you are going to start at n equals to 1 and end at n equals to k. This is your Tn, remember? So let us see if we can find the first 3 terms. So they want you to find the last term, k. Is it n is equals to 20 or n equals to 40, whatever, which gives us the total number of series from 1 to k, which gives us a sum of minus 20. So if you can make the first 3 terms, then you can use that. So let us take this. Minus 2, we are starting at 1. Minus 2n times 1. This is minus 2 times 1. Then the second term, minus 2 times 2. Remember, we are substituting in n. Minus 2 times 3. So these are the first 3 terms, which is minus 2, minus 4, minus 6. With these, we can find our common difference. So this is minus 4 minus minus 2. So that will be minus 4 plus 2, get a minus 2. Minus 6 minus minus 4, it's minus 6 plus 4, get a minus 2. So our common difference is minus 2. Our a is also minus 2. This will be helpful. So what are we supposed to find? K is the same as just saying find n. Remember, in our formulas, when you write Sn is equals to half n times 2a, I have the common difference, so I'll use the formula that has got the common difference. I don't have the last term, but I have the common difference, so I will use this formula, the expanded one. So remember, we say the n represents also the total number of terms, or the total number of terms in a sequence. If there are 30, the last term is also known as the 30th term. So we can use that to our advantage to manipulate this. So we know this n is going to be our k. Okay, so now Sn, we have it, minus 20 is equals to half times n times a, we have it, it's minus 2, 2 times minus 2 plus n minus 1 times our d is minus 2. (2n squared plus 2n minus 40 is equals to 0. So remember, we are looking for n. That's what we are looking for according to the question. The capital K is the same as n. Okay, so let's factorize this. 2 using the method of factorization. 2 times minus 40, we've got a minus 80. 8 times 10 will give me an 80. But what are the two factors? When I add them, they give me a 2. But they must give me a minus 80 when I multiply. A positive 2, I must put a negative here. So 10 times this, I get a minus 80, but if I add them, I get b, which is a 2. So these are the two factors. I'll substitute them here. The method of factorization, 2n squared minus 8n plus 10n minus 40 is equals to 0. It doesn't matter which one goes to the left or to the right. Let's factorize 2n, n minus 4, factor out a 10, n minus 4 is equals to 0, n minus 4, 2n plus 10 is equal to 0. So n minus 4 is equals to 0, or so n minus 4 is equals to 0, or 2n plus 10 is equals to 0. N equals to minus 5. Watch out, remember, n is supposed to be a positive integer, so this will not work. So k is the same as n. K is equals to 4. That's what they are looking for. So let us conclude with an example where we find a term using the sum of series. So far we've been showing how you can find the sum of series, but let's see where you can use those sum of series to find a term. Okay, so the sum of n terms of an arithmetic is this. So it has been given as a formula. Remember, this can also be written as a summation sign. Okay, now find the sixth term. Remember the formula we said, you said Tn is equals to Sn minus Sn minus 1. So we know we want to find the sixth term, T6. So it will be S6 minus S6 minus 1. So T6 is equals to S6 minus S5. Basically, this is what we'll be doing. So the sixth term is equals to, what's S6? We know what Sn is. So S6 will substitute a 6 here, a 6 here, and a 6 there. So S6, okay, let me just write the formula down first. 7n plus 15, 6. So this will be S6 and S5, S6 minus S7. So now this is S5, n over 2 times 7n plus 15. So outside the bracket, I've just put a 6 and a 5 to show that which formula are we referring to. Okay, we've substituted this into these. So term 6 is equals to, here we are substituting 6 over 2 times 7 times 6 plus 15 minus, here we are substituting 5 over 2, 7 times 5 plus 15. So T6 equals to, let's punch this into our calculator, 171 minus, let's punch this into our calculator, 125. So the sixth term is equal to 46. So this was all about how to familiarize you with the formulas and how you can play around with them. There are so many variations where questions can come and you have to play around with the formulas. Okay, that's it for now. Let's get on to geometric finite series.